Hello, today we're going to talk about volume. Volume is the amount of space that is in a 3D object. Basically, how much can it hold? So the first thing that we're going to talk about is a uniform cross-section solid. So shapes that have parallel faces have uniform cross sections, meaning that if I were to stand it up or stand the 3D figure up, it looks the exact same from the top to the bottom. The same type of figure, no matter where I slice it, I'll get the same shape. So let's look at example number one. So part A, it says we have a cylinder here. And the cylinder base that we're going to be looking at is going to be the circle. This is our bases. They're parallel to each other. So we want to use our volume formula. The volume formula states that your volume is equal to capital B times H. Our capital B stands for the area of the base. Okay, the area of the base. Whatever side you're sitting it on, you want to find the area of that shape. So remember, the area of our base here is that circle. So if I look here, I know that we need the volume formula, which is going to be that the volume is equal to the area of the circle, which is pi r squared times the height of the 3D figure. So we know that the radius, if our diameter is 17, our radius must be 8.5 because it's half of the diameter. So we can substitute that information in. So our volume is equal to pi times r, which is 8.5 squared, times the height of the 3D figure, which is 34. And we plug that into the calculator. And we're going to give our answer in three significant figures. So as we see here, our volume is approximately 7,720 centimeters cubed. All right. If we look at B, all right, so we have a triangular prism. So we need to find the area of the base. So in order to find the area of this base, which is a triangle, I have to know the height of the triangle. So if I put my height down the middle, I already know that each side of the base of the triangle is going to be 8. And if I want to use that to find the height of the triangle, then that means that I need to use Pythagorean theorem. So I'm going to have 8 squared plus h squared is equal to 16 squared. I'm going to subtract 8 squared on both sides, and I end up getting h squared is equal to 192. And from there, I end up getting that h is equal to the square root of 192, which is 13.9. And I'm going to use my approximate symbol since I am rounding. So now that we have that, we can now find our volume. So volume is equal to the area of our base, which is 1/2 base times height times the height of the prism. So we're going to have V is equal to 1/2. The base of the triangle is 16 times the height of the triangle, which is 13.9, times the height of the prism, which is 29 feet. So once we do that, put that in the calculator. And we would end up with approximately 3,220 feet cubed. All right. So now let's talk about example number 2. It says if a cylinder has a height of 7 inches and a volume of 2,908.33 inches cubed, find its radius. So we know that the volume of a cylinder is going to be V is equal to our area of our base, which is pi r squared, times the height. So we substitute the information that we know. We know that the volume is 2,908.33, and that is going to be equal to pi times r squared times 7, which is the height. So the first thing that we're going to do is we're going to take the 2,908.33 and we're going to divide by pi, or 7 pi. Notice how I put parentheses around the 7 pi. I wanted to divide the entire 7 pi on the bottom. All right, so when I divide that, I end up getting 132 in 3 significant figures. And that's going to be equal to r squared. And then I'm going to take the square root of 132, and I end up getting that the radius is approximately 11.5 in 3 significant figures. So just basically solving an equation. And we know that it is going to be in inches. Always put your units. So now let's look at tapered solids. Shapes that have cross sections that get smaller and smaller as you get closer to the top are called tapered solids. So an example of a tapered solid is a cone and a pyramid. So when we look at the volume of a cone or a pyramid, our volume is going to be equal to 1/3 times the area of the base times the height. So basically a tapered solid, it takes 3 of them to fit into one of the type of shapes, so to speak. So if we have a cone, it takes 3 cones to fit into one cylinder. If we have a pyramid, it takes 3 pyramids to fit into a prism. And then we have a sphere, which is like a ball or round shape. The volume of a sphere is equal to 4/3 times pi times r cubed. So let's look at example 3. It says find the volumes of the figures below, round your answers to the 3 significant figures. So if we look at this triangular pyramid here, we should see that our base is going to be this part at the bottom. This is our base. So that's what we need to find the area of. So one thing that we should realize is that this base has a right angle in it. Okay, we have a right angle. So if we have a right angle, we know that this is a right triangle. So if we need to know the height of it, we need to look at this side and this side because it makes a 90-degree angle, and we know that height should be perpendicular to a leg. So in order for me to figure out what the height of this triangle is, or depending on how you look at it, you can look at it and call it a base. All we know is that the base and the height should be perpendicular to each other. In order to find this missing side length here, I would need to apply the Pythagorean theorem. And I know that 24.8 is going to be the hypotenuse because it is across from the 90-degree angle. So if I were to use the Pythagorean theorem, I would say 16 squared plus x squared is equal to 24.8 squared. And if I have 24.8 squared, I'm going to subtract 16 squared from it, which is going to give me 359.04. And then I'm going to take the square root of it, and that will end up giving me that x is approximately 18.9. All right. So once I do that, I'm going to write in on my picture that this is 18.9 millimeters. So now I need to find my volume. So I know that the volume is equal to the area of the 1/3 times the area of the base. Okay. So the area of the base is a triangle. So I'm going to have 1/3 times 1/2 times the base of the triangle, which is going to be 16, times the height, which is 18.9. And then we have to multiply by the height of the prism or the pyramid, which is 21. All right, so when I put that in, I'm going to do 1/3. Type it in exactly how I write it. So I'm going to do 1/3 times 1/2 times 16 times 18.9 times 21. All right, and that gives me the volume is approximately 1,060 in three significant figures, and that's millimeters cubed. Right. So the next thing that we want to look at is we want to look at the volume of the sphere. All right, the volume of the sphere. We already know it is going to be that our volume is equal to 4/3 times pi r squared. So, r cubed, So, because we know our r is our radius, we know that our radius is half of our diameter. So, our diameter in this picture is going to be 38. So, we have to do half of 38, which is 19. So, we already know that our radius here is 19. So, it's going to be times 19 to the third power. So, if we were to put that in, 4/3 times pi times 19 to the third power, we end up getting that our volume is approximately 28,700 yards cubed in three significant figures. All right. If you have any questions on volume, please let your teacher know and have a great day.